Hello everyone, a very good afternoon to you all and welcome to this webinar on Hidden Gems in SolidWorks Discovery of Unused Capabilities. As this is our first webinar in the year 2024, we wish you all a very happy and prosperous new year on behalf of Logical Solutions. Let us move ahead into the agenda and see what are the hidden gems in SolidWorks that improve our productivity. And this is our agenda. We just have a glance on the agenda. We will reveal what are the hidden gems in SolidWorks that many of the users are not aware of. And let us explore those capabilities with the live hands-on session, and later on discuss on the advantages of the capabilities in our daily usage, and we shall wind up with question and answer session. And this is our agenda for the day, and you can see on the screen these are the hidden gems what we are going to cover today. You can see the 6 capabilities there. Capability 1 is property tab builder, capability 2 is walkthrough animation with SolidWorks, capability 3 is SolidWorks task scheduler, capability 4 is SolidWorks 3D interconnect, capability 5 is SolidWorks treehouse, and finally capability 6 is design standard checker. Let us go initially with the property tab builder. The property tab builder is a standalone utility that we use to create a customized interface for entering properties into SolidWorks files. The tabs that we create with property tab builder appears in the SolidWorks software on custom properties tab in the task pane. You can create different tabs. You can create different tab templates for parts, assemblies, drawings, and weldments as well. And now let us have an overview of property tab builder, and let us focus on the creating the tab and how to edit the tab and how to make use of the property tab builder. And now we can see here property tab can be opened in this way. We can directly go for window search and search for property tab builder, or else there is one more way to open property tab builder from SolidWorks user interface itself. Now let us move on to SolidWorks and see how can we open that property tab builder, and how to create the tab templates and how to edit those tab templates and make use of it. Now let us move on to SolidWorks. I hope my screen is visible. Okay, as I mentioned, property tab can be opened directly from SolidWorks interface, and this is my SolidWorks interface. On the right side we can find a task pane. Here there is SolidWorks resource, and in the SolidWorks tools we have direct option called property tab builder. Whenever we click on that, property tab builder can be opened. Okay, or else we can directly go for window search and search for property tab builder. What is the version of SolidWorks we have installed in our system? We can find the property tab builder of the same version. For example, if we have installed SolidWorks 2024 in our system, then we can find property tab builder 2024. As I'm having SolidWorks 2023, I'll be opening property tab builder of 2023 version. Whenever we click on property tab builder, you can see a tab has been opened here. The tab consists of this group box, text box, list numbers, checkbox, etc., and also custom properties and control attributes. In these control attributes, we can manipulate what is the type of template we are going to create. You can see a drop down here. We can create part template or assembly template or drawing template or weldment template. Now let us create a part template initially. Okay, and we need to mention the custom properties here in the meanwhile. So I'll simply drop a text box in this group box. And now generally while creating bill of materials, we generally use or else while using the part files, we'll be creating custom properties. For example, let us say I'll be creating an item number or quantity number here. Simply I'll enter a text. Okay, or else in the custom property attributes we can find the direct properties here, whether author, checked by. There are some predefined properties. Okay, let me go with part number. In the value also we can select whatever part number is required for us. Okay, we can select the predefined parts here, or else we can enter it manually. So I want to enter it manually, so I left it alone. We can set these custom properties as a configuration specific. Okay, and later on after item box I'll add one more text number. Simply drag and drop is the process. And let us create this as drawn by. Okay, and here we can find the direct property of that drawn by. Okay, we can enter the list of members who are there in our organization or who are there in our team. Let me add designer 1, 2, and 3. Designer 1 and 2 and 3, so that we can select whoever has designed that. They can select directly from the designer 1, designer 2, and designer 3. Okay, in this way we can create the tabs. I'm having a predefined tab I'm having a predefined template. Let me open the template and show you what else we can do in that and how to edit that. Okay, now for time being, I'm opening that predefined template what I have created.
Will be very
You can see
important.
here.
That will give you the code.
You can see here, this is my predefined template for my organization. I have created drawing number. I have entered supplier item number, and I have entered material and weight in kgs and unit of measure, category major, category minor. Whenever we select category major, for example, let me select mechanical. Then category minor will be these two options. Okay. Whenever I have selected major category as pneumatics or hydraulics, then the minor category will be changing, so that we can interlink those categories in this way. Okay, and here I am having one more tab, revision date, item description. These are the custom properties what my organization requires. So I have customized this property tab builder in a way which is useful for my organization. Okay, now I'll save this template. Okay, I'll save this as a as a part template, and whatever we have created in the property tab builder, we need to specify the same location in the SOLIDWORKS user interface. Let me open the settings, and then let me move on to file locations. And in the file locations, we can find here custom property files. In these custom property files, I have saved my property tab builder template. Or else, if we want to specify one more location, we can simply delete this one and add that location whatever we require. So I have saved my property tab builder template in this location. So I have given the location in the custom property files and have given this folder. Okay. Now let me create a small part here. Now I have created a part. You can see a small part here. I have added my property tab builder template in the file locations. So it will automatically reflect here in the task pane. In the task pane, we can find custom properties. On the right side, you can see here. Whenever I have clicked on custom properties, as there is only one template, it has been automatically selected. You can now see here the same properties what I have given in the property tab builder has been reflected here. Drawing number, supplier item number, whatever inputs we will be giving here. Drawing number 1, supplier number 2, and material. Let me select 1060 LOI. Okay, weight in kgs, and then unit of measure. Let me select kgs. Okay, major category coming to mechanical, and category minor I'm going to select manufacturing, and I'm going to select a revision, and I'll select the revision as A1, and it will automatically gather the revision date and item description. Now after selecting all the inputs in these custom properties, now I'm clicking on OK, so that you can find all those things in custom custom properties of the file. You can see here whatever the inputs we have given, this all will be reflected in the file properties. For time being, let me close this one, and I have entered the properties for the assembly. Let me open that assembly, and I have opened an assembly of universal joint. So here I have given predefined inputs so that I can generate everything in the bill of material. I have also created a bill of material template. Let me create a drawing for this. Okay, I have opened a drawing for this, and now let me create a bill of material. I'll simply select table, bill of material, and select this view, and I'll be selecting the bill of material template. I have created one more template for bill of material, and now I'll go and select that template. Okay, and whenever I have selected that, you can see the list of documents here, the list of properties here. Whatever I have given in the property tab builder and the inputs whatever I have given there has been reflected here. You can see the drawing number, part number, supplier item number, quantity, material, weight, unit of measure, major category, minor category, revision date. Everything has been deployed to bill of material. Okay, and now I can see here this crank arm, one of the part has not been given the properties. So let me give the properties using the property tab builder. Remember this item number, crank arm. So let me go to the crank arm, I can find it in this crank arm, crank subassembly, crank arm. Open that part, and from the task pane I am having custom properties, and from here I am giving the inputs. Simply let me give the drawing number as 1.2 as it is in one of the subassemblies. So supplier item number 2, and let me give the material as 1060 alloy, unit of measure in kgs, major category as whatever we select the major category, related to that only the minor category will be coming. I have given this minor category as manufacturing and revision as A1, and then I'll click on apply, so that I can see here in the file properties, the properties has been reflected here, and I'll save this one, close this one, and I'll save this assembly also. Okay, and let me move on to the drawing, and we can see here the crank arm has been the crank arm properties has been displayed in the bill of materials also. In this way, we can make use of this property tab builder. And now let me give a brief description of the advantages of property tab builder. Custom property tabs can help you to increase your efficiency by allowing you to quickly access the information you need about the models. This can save your time and effort and help you to get your work done more quickly. Custom property tabs also can help you to communicate more effectively with your team members by providing them with your information they need about your models. This can help to avoid misunderstandings and errors and ensure that everyone is on the same page. And this is the major use of the property tab builder. And now let us move on to the second capability. And now capability 2 is walkthrough animation.
What is walkthrough animation? Walkthrough animation in SolidWorks refers to the process of creating a dynamic virtual tour of a 3D model or design created in SolidWorks. This type of animation allows viewers to navigate through the model as if they were physically walking through it, providing a detailed and realistic visualization of the design. It is commonly used for exploring and communicating the 3D geometry, spatial relationships, and addressability related to design features of SolidWorks model. Walkthrough animations are useful for presentations, design reviews, training and instruction, marketing materials, virtual prototyping, and client communication, as they offer an immersive and interactive way to showcase the design and its functionality. Let me go through an overview. So like this, we can make a video in walkthrough animation. And before going through the hands-on, let me discuss about the controls. These are the controls. Here, if you see this, if you see the control bar, there it is given: moves the avatar forward, turn the avatar right, turn the avatar left. What is avatar? Avatar means the path which we are going. The path which we are going through the 3D model is termed as avatar. The avatar is nothing but path. So here, the first image indicates motion controls, in which this up arrow moves forward, down arrow moves backward, and this turn left and turn right, and one is rotating anti-clockwise direction and another is rotating clockwise direction. And coming to this blue up and down arrows indicates moving up and down. That means if you are walking in the ground floor, suddenly if you want to move to the first floor and second floor, then these kind of arrows can be used. And coming to the extreme right, we have two symbols, that is one is rabbit and another is tortoise. So the speed is termed in terms of rabbit and tortoise. If we click rabbit, the speed increases. If we click tortoise, the speed decreases. Generally, the speed ranges from 1 to 9. And coming to the view options at the bottom, the difference between the motion commands and view commands is, in motion command, we can move forward and simultaneously we can observe everything. But in case of view command, only the person will be stationary, as if like the person will be stationary, and just like our rotating head moving this side and that side, up and down, the person will be stationary and moving, head will be moving in that way. Here we can't move. And the adjacent, zoom in and zoom out. Coming to the top, home options. Here there are two home symbols. One is default home provided in software, and the below one is user defined home. That means the starting point or the ending point which we can define, and that will be plugged, and that will be termed as foam. And coming to the right side, the top one is a map, because as we employ this process in big buildings or as well as power plants, we should be aware where we are traveling in terms of map. There it is useful. This creates a small map at the extreme left, and this middle red button indicates recording. If you press this, recording starts. You can see the recording options also below, and this lock symbol below indicates by we can go through a user defined default path, or if we want, you can specify a path in terms of sketch also. Yeah, we can lock that sketched path. So for that, this locking option is useful. Let me dive into the software for a better understanding. This is opened in large design review mode, because even though if you open with the resolved mode and as well as lightweight mode also, we can go through walkthrough, but mostly preferable is large design review mode, because you can find it more flexible and you can have direct options. So at the top you have an option called add walkthrough. If you click this, in the left side, the property manager, you can have start walkthrough option. Before clicking the start walkthrough, let us see the viewport settings. In viewport settings, one edge is selected for reference purpose, and here in the graphics window you can see a arrow mark, a green color arrow mark pointed upwards. Sometimes at the bottom, if there are some things, we can go bottom also for navigation purpose with the down arrow. But here only above the base only the parts are present. That's why we choose upper arrow. And here there is a distance 1650 mm. That means this is by using this distance you can specify at what height from the base you want to travel. Here 1650 mm we will be traveling, and in between, even though if we specify the particular height here, in between you can increase the height or you can decrease the height based on the controls. So let me go start the walkthrough. Start walkthrough, click it. As I have said previously, you can see the motion commands as well as view commands and as well as record options. So here there are three classifications. You can use this. Suppose move forward, you are moving forward. Move backward, same. Move clockwise direction, anti-clockwise direction. And I don't want to move on the ground, I want to go to first floor. You can click this up. So at certain height, more height, you can move forward again. So you are moving at the second floor. And I want to go down. At this point I want to go down. I want to go to ground floor. Okay, I am at the ground floor now. I am moving forward. So like this you can navigate to the entire power plant here. And from here, okay, now you want to view from here. As I already told you, these are the view options. At this point of view, you can view everything. I can view the sky, I can view the ground, I can view this side, the right side and the left side. And if I want to reset the view, the center button is for that. Reset view. Click it and reset the previous view where you have started. And here at the extreme top left corner, you have map view. If you click this map view, it disappears. If you again click this map, it appears. And recording bottom. See here, if you click this red button, recording starts. You click this, recording starts. And after clicking OK, recording stops. It will be saved automatically. And here, if you click generate video, the video will be automatically saved. But as of now, if I click this, it takes some time, because the video should be saved frame by frame. It will be taking a couple of minutes. So we have already recorded a video which is available. Please have a look. This is the generated video of a walkthrough at certain height. So like this, you can view each and every corner of the power plant. you can have a 360-degree view of your desired part, and you can take a snapshot also with the option provided at the top.
And let us move on to capability number 3, SOLIDWORKS Task Scheduler. The SOLIDWORKS Task Scheduler lets you to set up the task to perform at the future time, and if we need to perform a resource intensive task such as rebuilding a large assembly, we can make use of SOLIDWORKS Task Scheduler to perform the job at off-peak hours. We can schedule a task to be performed only once on daily, weekly, or monthly basis. SOLIDWORKS Task Scheduler runs separately from SOLIDWORKS application. We can also use SOLIDWORKS Task Scheduler without any SOLIDWORKS license to convert documents to the latest SOLIDWORKS version or to dissect documents. To schedule most of the other tasks or to schedule disturb file conversion, we must have a SOLIDWORKS professional license or SOLIDWORKS premium license. And now we can open SOLIDWORKS Task Scheduler. As like the property tab builder, we can go for Windows search and then we can open it. Okay, and this will be installed along with SOLIDWORKS, and we can open directly. Let us go to Windows search and search for property tab, task scheduler. And here is Task Scheduler 2023. For each and every version of SOLIDWORKS you will be installed, it will SOLIDWORKS Task Scheduler also will be installed. Let me open this SOLIDWORKS Task Scheduler, and we can see the task slide bar here. Okay, there are different tasks that we can perform here. There is convert files, where we can convert SOLIDWORKS files and that are created into an earlier version. There is update files, where we can rebuild the specified files, and there is update associated files, which rebuilds the specified file plus any associated files in the specific folder. And also we can make use of these print files to print the specified files using default document printer settings or any other selected options. And there is import files, where we can import step file or IGS files and we can save that into the SOLIDWORKS documents. And there is export file, where we can export our SOLIDWORKS documents to another file format such as DXF or DWG or IGES or step file formats. There is update custom properties, where we can add or modify custom properties into the specified files. There is create drawings, where we can create parts or assemblies using the specified drawing document template. There is convert high quality views, where we can convert our drawing views from draft quality to high quality. And there is run custom task, where we can run applications using macros or any other command line arguments that you can specify. We can also create e-drawings using SOLIDWORKS parts or any step files, etc. And we can also update our simulation analysis in the specified files. Okay, and we are having design checker. This is one of the interesting capability where it will be covered in the further capabilities in this session. Where we can check our SOLIDWORKS documents is as per the standards according to our standard files. And there is render and animation, where we can manage rendering and animation task. And there is build ECAD files, where we can build multiple ECAD files used by CircleWorks as a SOLIDWORKS solid models. Okay, and here is our task. Here is our task column, where we need to specify the task what needs to be done. I'll go with import files, which is the major task what we generally face. Okay, let me create a task from the slide bar. Now I'm going to export files. I'll generally we convert drawing files into PDF files. I'll do the same here. Export file type. Here are the different file formats where SOLIDWORKS Task Scheduler is capable of. Okay, and there is a direct option .pdf. I'll select that one, and here are two options. Either we can add one particular file which need to be converted from drawing to PDF, or else we can directly add a folder where we can the drawing files in that folder will be completely converted to PDF. I'll add a folder so that it will so that all the drawing files will be converted into PDF. Okay, and now I'm going to convert the drawings in this folder. There are multiple drawings in this folder. So I have selected this drawings folder. Okay, we need to specify the time, and I'll specify it a minute. As it is 3:35, I'll specify 3:35. Okay, and then if you finish the task will be created there, and whenever the task will be completed, if we can see the progress here. In the meantime, let me open the task scheduler. Let me open SOLIDWORKS. Let me open this presentation. Okay, it will, so that it will be completed in the background. And in the meantime, by the time this drawing files gets converted into PDF, let us have a glance on task scheduler advantages. And here are some of the advantages of task scheduler. The task scheduler automates repetitive tasks, saving the time and efforts for the users. This can be particularly beneficial for the tasks that need to be performed regularly, such as generating reports, update drawings, or running simulations. The task scheduler offers flexible scheduling options, allowing users to specify the exact time and frequency for the task to run. This ensures that tasks are executed at most appropriate times, minimizing disruptions to workflow. The task scheduler is a reliable tool that ensures that tasks are executed as scheduled even when the users are away from their computers. This helps to maintain productivity and ensures that important tasks are not missed. By automating tasks, the task scheduler reduces the risk of human errors that can occur during the manual execution. This improves the accuracy and consistency of the task to be performed. The SolidWorks task scheduler is seamlessly integrated with SolidWorks, making it easy for the users to have access and manage tasks directly within the software. This simplifies the workflow and eliminates the need to switch between the different applications. So these are the advantages of SolidWorks task scheduler. In the meantime, I hope that conversion of drawing files to PDF will be completed. We'll just have a look on it. Okay, we'll have a look on it. Okay, and have selected drawing folder from here. Let me select if the drawings are created. You can see here there are different drawing files, and as well as let me show you in detail. There are drawing files as well as the PDF file. Okay, you can see each and every drawing file is having a PDF file also. Okay, this has been converted through SolidWorks task scheduler. You can see that here.
Capability number 4, another hidden gem, 3D interconnect. What is 3D interconnect? 3D interconnect, SolidWorks has always delivered first-class capabilities for working with both neutral and native CAD data from various sources. We do have groundbreaking hidden capabilities with 3D interconnect that unlocks new collaborative possibilities with your customers and suppliers with the integration of native CAD files directly from BTC Creo, Autodesk Inventor, Siemens, NX, Solid Edge, and CATIA. So, advantages with SolidWorks interconnect is if we want to import any CAD file into SolidWorks, then we must either convert it into neutral file or step file, and it should be converted into part file. Then only it can be used and mingled with the SolidWorks files. But now, due to 3D interconnect, no translation into SolidWorks format is necessary. By using 3D interconnect, simply insert them into your assembly just like any other SolidWorks file, and they are treated like a native components. So these are the following formats which are supported by using the 3D interconnect into SolidWorks. That is CATIA V5, PTC, Solid Edge, NX software, 2D formats, JT, Jupyter Tessellation, IFC, neutral files, and CATIA V5. The 3D interconnect utility allows you to import third-party CAD files that were created in other CAD systems. This is done directly without any conversion into a SolidWorks file. Controlling the 3D designs from the different CAD softwares had become easy. We can work directly with supplier and vendor without considering any barriers between CAD software. In this example, we can see an entire Autodesk Inventor's assembly structure of a battery design within SolidWorks Feature Manager design tree, which is situated in the box. This is related to the Autodesk Inventor files. Here, managing these components with any SolidWorks is same as SolidWorks database. Same here. If you see in the screen, while fixing these two, the two planes are automatically joined. Now, 3D interconnect directly references the native CAD files and is always aware of changes taking place. Here, not only the components are updated, but also the mates are also remain intact. When 3D interconnect is aware of phase and edge IDs in the native CAD files, meaning there are no errors or problems to the holes and rivets. Sometimes if we want to do changes, with the files from the third party, 3D interconnects lets you open these files. If you want to create any bracket, bracket is created, automatically the rivets and joints are automatically updated. For example, you may need to add a keyway to a gear, even more complex features that references, faces and edges of the native CAD data. Here what happens, we open the gear, gear of the pulley, and as we do it in SolidWorks, we drag the keyway from the library. Here also we will drag the keyway from the library and it is placed on the edge. Keyway is formed, and this keyway is formed, and the units are set as per our standards, and this gear with the keyway is dragged into any assembly as we do it in the normal native SolidWorks files. SolidWorks even understands the PTC Creo version files, which often have a revision suffix in their file name. SolidWorks treats its unique additional file like any other change and notifies you like it did within the assembly. Choosing an update model replaces the geometry referencing the original CAD data. Everything updates as expected in both the part file and assembly. Nothing else is required. In addition to this, let us have a glance on the additional information, that means additional features which SolidWorks 3D Interconnect provides, that is assembly cut features. What all we do in the assembly of PTC Creo and UG files, that will be automatically transferred to SolidWorks files, like custom properties, material properties and unconsumed sketches. Unconsumed sketches means it may be the sketch which is not converted into feature, or it may be a separate dangling entities. And reference access from CATIA B files also can be effectively replaced with SolidWorks files in the database.
So let us continue with capability number 5, SolidWorks Treehouse. In SolidWorks Treehouse, we can set up our assembly hierarchy in a graphical user interface before we build the model in the SolidWorks user interface. And in SolidWorks Treehouse, we can also drag parts, assemblies, and drawing nodes into the graphic area to create the file structure. And also we can edit the properties there itself. We can add configurations for that, and also we can suppress or unsuppress the components and component instances. So let us move on to SolidWorks Treehouse interface and just have a look on it. How can we create this file structure and how can we export those file structure to SolidWorks user interface? Okay, let me open SolidWorks Treehouse. This is also similar to Property Tab Builder and Task Scheduler, which will be installed along with SolidWorks, and this is also separate application along with SolidWorks. Okay, you can see SolidWorks Task Scheduler SolidWorks Treehouse has been opened now, and you can see there is a template, part, assembly and drawing, and there is one more option here, existing template, where we can existing file where we can open the existing assemblies or drawings so that we can verify it in a structured way, or else we can create our own assemblies and own parts or own drawings. Okay, this will be very helpful to us before designing itself, so that we can estimate how many number of assemblies, how many number of sub-assemblies and parts need to be done to the assembly. And we have treehouse settings here in the bottom, in the right side bottom. We can specify template location, or else we can import or export, and we can play with these options. Okay, and there are a few more options to zoom in, zoom out, and then this is to add the destination path. Okay, and this is to create a new treehouse file, and there is an open option, the save option. This command export to SolidWorks documents will directly export all the treehouse components to SolidWorks documents. And there is one more option, open in Excel. The file structure can be directly exported to Excel, so that it will be easy to prepare our own bill of material. And there is one more option, print, so that this file structure can be directly released to print. Okay, initially let me create a short assembly to showcase you how can we export these assemblies to SolidWorks user interface. Okay, let me simply drag and drop one assembly here, and I'll name it, let us say we are going to create an electrical engine, so that we can manage in that way. Okay, this is my main assembly with the name electrical engine, and I want to add gears to that. So I have added one assembly there, and I want to add electrical machine to that. So I have added one more assembly there, and now I want to add one more inverter to that. So I'll add a simple part there. Okay, and now I'll simply rename these things. I'll name it as gear assembly. Okay, I'll name it as electrical machine. Okay, and now I'll name this one as inverter. Okay, and to this gear assembly I'll add two more parts here. One is gear 1 and one is gear 2. Simply we can drag and drop and place on that structure there. So in the same way I'm dragging one more part here. In the electrical machine I need one stator and rotor. So I'm placing two more parts here, and then this is my assembly. So we can rename the part also. For time being, let me directly convert this one. We can directly export this to SOLIDWORKS document. I have a predefined for time being I have predefined document where I have converted this into exported to SOLIDWORKS document. Let me open that. Let me open SOLIDWORKS first. Okay, let me open that. Let me open that assembly where I have saved. Okay, I'm having electrical engine here. This assembly consists of this assembly is completely an empty assembly where we can create in a top-down approach, or else we can insert components and then we can model it. And you can see here I have electrical machine sub-assembly, I have gear sub-assembly, I have inverter sub-assembly. I have renamed the parts inside that. Inside that electrical machine, I have created two more parts, stator and rotor. And in the gears, I have created gear assembly there. And you can also see there is one more part inverter. In this way, we can create our assembly. And whatever component you want to create, you can simply open this part and then create that model here itself. Okay. To make any cost estimations, or to make how many number of components can be required for an assembly, this can be very useful. And one more best part is we can also export these to Excel sheet. We are having a direct option here, open in Excel, open structure or open parts. Let me go with the open structure, and I can see here this can be directly exported to Excel with the default configurations and the number of quantity and the name of the parts. Okay, this makes very simple for our process to go or to design or to cost estimation in the before itself. And this is what all about treehouse. Let us see a few more advantages regarding this treehouse. SOLIDWORKS allows you to create precise and accurate drawings, which is essential to building a safe and sturdy treehouse. With SOLIDWORKS, we can also customize our treehouse to meet our specific needs and preferences. We can choose the size, shape, and layout of our treehouse also. Okay, and these are some of the uses where we can edit the file properties, or else where we can add configurations and drag the existing documents for the treehouse from Excel from Microsoft File Explorer. Okay, let me open an existing file and show you how can we view those. Let me open this universal joint here. Just a second. We can also open our existing assemblies here from this open command. Okay, and this is all about treehouse. Let us continue with the remaining one more capability, which is design standard checker.
Design standard checker. What is design standard checker? Basically, here the person who is using SolidWorks, that means if I am a user, I'll be setting some standards, and I'll be saving it with, I'll be creating a standard. I'll be saving it in the form of template, and I'll save the template. And what I will do, I will be taking in active documents currently flowing in the design, and I will check the document whether it is as per my required standards with the template. And if there is any mismatches, that will be highlighted and that will be tried to solve there itself. So this is the SolidWorks Design Checker. This is an add-in which verifies the design elements such as dimension. It may be dimensional standards, fonts, materials, and sketches and whatnot. So let me dive into the software for better understanding. Before going to it, let me check whether it is that add-in is active or not. I'll go to add-ins and I'll check it. Here, if you see, SolidWorks Design Checker is not active. I'll make it active by checking the tick mark. Now it is active. I'll close this. Now I'll open a document which I have to check. A simple ratchet body. I'll open this. Before checking this, let me show you my standardized template. That is, to open that, I'll go to Tools, Design Checker. Here there is an option called Build Checks. If I click this, a dialog box opens. It is written create a new standard file, open an existing standard file. If I want to create new standard file, I'll click the above one. As I told you, I have already created a file and I open the existing standard file. I'll click this, SolidWorks Design Checker 3, open. So this is my required standards. There are tabs like the document checks, annotation checks, dimension checks, drawing, part, assembly, as well as feature checks. So it is not mandatory to modify each and every parameter. As per my requirement, I have modified some parameters. Like dimension standards, I have set to ISO. Units, I have set to mmgs, millimeter gram second. Reference up to date. References should be up to date. That means rebuilding, automatic rebuild. I have clicked. And the next one is annotation checks. I have specified the arrow like this. That means not a solid arrow, but a transparent arrow. And I have also gone with tolerance data. Then coming to standard, drawing standard, I have specified the standard template as A4 PSI, that means the British standard. Display style as shaded. I don't want hidden lines, wireframe, etc. I want only shaded. Coming to this assembly, component material, I have given the material of zinc for all the components in the assemblies. And fixed parts. With fixed parts also, I need two parts. Minimum two parts should be fixed in the assembly. So this is my criteria. With this criteria, I have made a template. And let me show you the summary view of the standard of my specifications. ISO, mmgs, what all I have explained you. This is the summary. And now I'll be checking all the three environments, like one part, one drawing, and one assembly with reference to these options. So let me close it now. So here, same, insert, design checker. Previously we went for build checks. As the document is already ready, we will click check active document. See here, At the top you have add standards plus symbol, minus remove standards. I have some more standards also, like design checker 2, design mock demo, tutorial, etc. I can employ all the 4 standards also. That the result output will be the average unit of all these 4 standards. But in order not to complicate, I can check 4 also, but as of now I'll be checking with only 1. That is SolidWorks design checker 3. Simple. I'll click check document. I'll click it automatically. So these 3 are the mismatches. That means in these 3 aspects, my standard is, the document is not meeting my standard. The first one is, if we click the first one, ABC ratchet body, here the information displays. That means what is the actual one, what is the preferred one, what is not matching, etc. And here there is an option called autocorrect all and correct selected. Here, even if we click autocorrect all also, each and every mismatch will be corrected. But it is general suggestion that we have to check each and everything individually and we have to correct. It's a best practice. So here there is no database set allotted and no material was specified. If you see in the feature manager at the left, earlier the material is not specified. But my requirement is I should specify the material as zinc. I'll click correct selected. If we click, automatically the zinc material is assigned to the solid. If you see in the left side, the material has been changed and zinc is allotted. Okay, and the next one, unit system. Actually, it is by default, it is custom. Here at the bottom, it is shown as custom, and my requirement is mmgs, millimeter gram second. I'll click correct selected. Automatically at the bottom, you can see it is changed to, in the status bar, it is changed to mmgs. And the third one is ratchet body. If you click it, here the actual value, the dimensional standard value is ANSI, but my requirement is ISO. I'll click it. I'll fix it. Now I'll go with recheck document. Here at the top there is a symbol called recheck document. I'll click it. Now the message is displayed, your document is as per standard. And one important disclaimer here, not each and everything will be fixed here. Some can't be fixed. Some should be fixed in the relevant environment itself. So design checker point out the mismatches. It tries to fix each and every mismatch individually, but some can't be fixed. Some should be fixed in the relevant environment. So in the same way, let me rush into the drawing environment of the same solid body. I'll close it. I'll open the drawing of the same ratchet body. Open. Save. Check AQ document. Check the document. Document is checked. Here are 3 mismatches. Ratchet body sheet 1. The change in units IBS, MMGS should be changed. Correct selected. And later ratchet body sheet. Here the sheet is sheet modification is sheet standard is ANSI modified. I need ISO. I'll click correct selected. And the next one is standard template. Here it is A3. And the type of projection is third angle. If I click this, the sheet is changed to A4. And I'll reorder this, readjust this one. And there are 4 views. If I click this 4 views, I have a common preferred value, that is shaded. I can go with view 1, view 2, view 3 individually, or simply the top one. If I click this, so as the property is common to all, I'll click correct selected. Automatically all the views will be displayed to shaded. And I'll again click for recheck document. Automatically it displays your document is as per standard. So this is about drawing. Let me go with a small assembly, that is universal joint, a small assembly. And small universal joint. Click open. Save. Click design checker. As it is on, it is activated. You will be having a display in the taskbar. Check document. Universal joint. Standard should be modified. Correct selected. Fully defined sketch. Here it is indicated that this as the sketch is not properly constrained, but this should be corrected in the path module, not here. That means that these things can't be solved by using design sketcher. As we don't have option also. If you click even edit sketch also, it is shown like this. Fail to edit the sketch. Assembly documents, universal joint, and my specification is I need 2 fixed parts. Actually, it is only 1. This also can't be corrected because this should be corrected in assembly module. And here I have assigned each and every body, each and every component with the same material, that is zinc. I'll click the main one and click correct selected. Automatically each and every component in the assembly assigns the material of zinc. If you go with this, if I click recheck document also, everything will be okay, but these two can't be solved. So this should be solved in the respective environments.
The design standard checker is also completed, and these are the 6 capabilities and 6 gems of SolidWorks which are hidden and many of the users are not aware of.